Welcome to Chapter 8. Also, welcome to the online version of this course. Today, starting Chapter 8, we're going to be talking about inverse variation. We have actually 4 things we have to go over. The first one is we're actually going to talk about inverse variation as far as what it is and what it looks like. Then we're going to learn to write our own inverse variation equations from descriptions given in the book. Then we're going to talk about how to determine from a table which type of variation you have. And lastly, we're going to talk about writing joint variation equations, which is similar to writing the inverse variation equations. So let's get right into it. Direct variation, which is not what we're talking about today, is something that we talked about way back in Chapter 2. So in case you don't remember it, we're going to go over it briefly. Direct variation is characterized by an equation y equals a times x, where a is some number, a constant, and then y and x are our variables. Direct variation produces very predictable tables. This is an example of a direct variation function. The x's and y's here are listed in a tabular form. The thing you'll notice about direct variation is that every time x goes up by 1, y is going to go up by some other amount. We also call this slope in other contexts. In this case, we actually call that the constant of variation. It's the same as a value. So this particular function in the table, since y goes up by 3 every time x goes up by 1, we know that a is 3. Now you can find a at any time from any row in the table by taking the y value and dividing the x. And that's going to tell you a. So 9 divided by 3, that's 3. 6 divided by 2, same. In a direct variation equation, dividing a y by its x will always give you a, and a will always be the same no matter which row you use on the table. That was direct variation in a nutshell. Now, inverse variation is sort of the opposite of direct variation. And it works like this: y equals a divided by x rather than a times x. As you start looking at tables, you'll note when x goes up by 1, y is going down. It's getting smaller, but the pattern is kind of difficult to discern. I mean, it goes down by 1 and then a half, and who knows, you get all these fractions. So it is going down. It's not as easy for your brain to kind of see the pattern this way. But if you look at each row and take the y and compare it to the x, what you'll find out is that for inverse variation, multiplying the y times the x will give you the same value every time. In this case, 6. 2 times 3 is 6. 3 times 2, 4 times 3 halves will give you 6, as does 6 times 1, 5 times 6 fifths. Now, you can actually, if you forget this particular equation, you can get it from here just by solving for a. To solve for a, you multiply by x, and that's why a has to equal x times y. But that means on a given table that's inverse variation, multiplying x by y will always give you the same answer no matter which row you pick, and that'll also tell you what a is, the constant of variation. As far as the graph, we're not going to be graphing these today, but we will soon, and so I want to talk about the graph a little bit. This is 6 over x, the one we saw in the table for. Notice 1, 6 is on there, as is 6, 1. Also 2, 3, 3, 2. The others were fraction values, but you get a nice smooth curve here. If you zoom this out, you'll see this behavior, which you should recognize because last chapter we had asymptotes. These are both asymptotes. There's a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. So this graph actually has both vertical and horizontal asymptotes. If you extend this over to the left for the negative values, you get the same curve over here. It's just they're negative. So any point over here has a corresponding point in the third quadrant down and to the left. Notice the asymptotes work both on the right and the left, the horizontal asymptote and the vertical asymptote. This shape is called a hyperbola, which is not a word I'm going to make you use ever, but just so you know, this is a hyperbola. As far as writing the equations, which is what you actually have to be able to do today, usually these problems present themselves in a way similar to this. The variables x and y vary inversely, so that's information about what your equation looks like. then y equals 7 when x equals 4. Your first pair are a pair that go together. If you made a table, the 4 and the 7 would be on the same row. We're going to first write an equation relating x and y. Then we're going to find y when x is negative 2. So we've been given one row on the table. We need to complete a different row on the same table. The best way to approach this is to start by remembering inverse variation and what the equation looks like. So we need to figure out the equation, which is always, for inverse variation, y equals a divided by x. Now in this case we know one pair, so we can stick 7 in there for y and 4 in there for x. Now this is a intermediate step. What we want is an equation with x and y in it, but we do need to find the number for a. Once we stick in 7 and 4 for y and x, a is the only variable left and we can find a. We do it in this case by multiplying by 4, so 7 times 4 is 28. Make sure you actually write the equation, especially say on a quiz or a test. If the instructions say write an equation relating x and y, make sure there's 1 in your answer if you want all the points. Then we're going to find y when x equals negative 2. So we just put negative 2 into our equation here, and we get 28 divided by negative 2, which is negative 14. If this is your instruction, note it's got 2 parts. Write an equation, then find y. So we need to make sure we have the equation, and we need to make sure that we find y. Every year, some of you forget to do the first part here. And every year I remind you, just don't forget this year. All right. Moving on. Verifying variation from a table. This is 3 tables. It's actually 2 different types of variation and one that's neither. So if you think back to what we talked about at the beginning of this lesson, the easiest way to verify variation is to take a row and compare it. So in a direct variation, the constant is always going to be y divided by x. So taking the y value and dividing by the x value should give you the same answer for the entire table. For inverse variation, you have constant products. That is, x times y is the same. You may also find a table as neither. So if we look at the first table here, y divided by x, that would be 8. 4 divided by 2 is 2. It's not the same. So it's not direct variation. 8 times 1 is 8. 2 times 4 is 8. 3 times 8 thirds. Oh, that's 8. This one is the inverse variation equation because the products are always the same. This one here, looking at them quickly, this one is the direct variation equation, or table, I should say, because 4 divided by 1 and 8 divided by 2, these are all 4 when you divide. The one in the middle is neither. When you start dividing, you'll get 4 and then 3 and then 4 thirds. So they're not all the same when you divide. They're not all the same when you multiply either. 8 for this product and 12 for this product. This one is neither. So we've got a inverse variation, neither, and a direct variation. Joint variation is very closely related to other types of variation. Now, with joint variation, what you have is a quantity that varies directly or inversely with 2 other quantities, usually their product. This is your basic idea. This would be for a direct variation or direct joint variation. So Q here varies jointly with x and y. Q varies directly with x and y. You always have to include a constant of variation. You can use an A. Sometimes people use a C for constant. In German, actually, the word constant starts with a K, so K's show up frequently as well for this. As an example, the temperature of a gas varies directly with the product of its pressure and volume. So the temperature of a gas varies directly with the product of its pressure and volume. You need a constant, A, so T equals A times PV, where temperature is varying directly with the product of, this is a joint variation here. Now the same relationship, if you put it on its head and think about pressure varies directly with temperature. We learned that already. But pressure varies inversely with volume. So you need your constant, so we put the A here. But pressure varies directly with temperature and inversely with volume, gives us 1 on the top and 1 on the bottom. As far as actually performing these. Here's a worked out example for you. It says write an equation relating x, y, and z, given that z varies jointly with x and y, and that z is 60 when x equals -4 and y equals 5. Then find z when x equals 7 and y equals 2. So the first thing we're going to do is very similar to what we did before. We're going to take our values, we're going to stick them into our equation. Now, if z varies jointly with x and y, we've got z equals some constant times x times y. We stick in the values we have, and now we can find a. -4 times 5 is -20, so when we solve for a, we'll get -3. That lets us write our equation. Z equals -3xy. Once we have our equation, we can stick in x's and y's as we have them and find the z that goes with them. In this case, -3 times 7 times 2 is -42. That should be enough to get you started. You can give it a try at the exercises. Let me know if you have any questions. And don't forget to upload your answers or a picture of your work.